Class 199. Types of hydraulic actuators. It can be linear and rotary. Okay. So linear actuator means it will have a cylinder and piston. See here, cylinder and a piston. Piston is also called as barrel. Both are same figure. Okay. So here, this is, see, you can see here, when fluid enters here, okay, fluid enters here, piston will move to the right side. You have here two ends. This is called as rod end. This is called as rod end towards right side of the piston, and left side is called as blank end or blind end. This is blind end. Okay. When the piston moves towards rod side, we call it as extension stroke or extension. When it moves in the opposite direction, we call it as a return stroke, because normally piston will be towards this side, left side, because of spring tension. Hence, return position means to the left side, rest position. When we want movement, we will pass fluid through the inlet port. Here it is shown here and here it is shown here. Piston will be forced to move to the extension end. A small air ventilation is given here so that when piston moves here, air is free to go outside, else the operation will be sluggish, because air also here will become compressed. So small air vent is given here. So when pressure is released due to spring tension, it will return. Symbol you need not bother. This is called as single rod, single acting cylinder. Next we have single rod, double acting. Single rod. Rod is only one, but double acting. Here instead of spring, okay, here you have spring and fluid pressure. Here at both sides you have fluid pressure. If fluid is pumped in here, say left in the left port, you will see advancing in this side. Rod will move to right side. If we pump the fluid pressure or fluid at pressure to the right port, piston will move to left side. So this is single rod and double acting cylinder. You have double rod, double acting, many types are there. You can do Google search if you are interested. Here there is what is called as piston seal. Okay, this seal is provided to prevent leakage of fluid from entering from the blank end to the rod end, means from this side to this side. This is air side. Okay, so here there is piston seal. Like in pressure cooker you have a belt. Okay, here seal is shown like this. Okay, so this is regarding with the hydraulic system. And the symbol, you see, actually no need of the symbol for you. Simply, so this is 4 by 3 directional valve. Means see, in the middle port, it will be numbered A, B, P, T, and dash dash means it is blocked. Central position or neutral position, no flow. In the left position, two flows will be there. Say P to A, P to B, and A to T. P to B and A to T. You can see here. See P A direction. Say that this is P T A B. P T A B. Same thing. P T A B. P T A B. P T A B. Okay. P and T are left side, bottom. Okay. A B are on the top. In the right side, you can see flow is from P to A. See, when you see straight, you come and see here. Okay, P to A. You can see here P to A. See, from P to A, it is flowing. Here it is P to B. When you rotate the spool, it goes to P to A and T to P. T and B. T to B. Note that there is no connection between this path and this path. The drilling will be such that, see, you have here cylindrical or tube. Okay, one drilling will be here, another drilling will be somewhere else, or even though at same position, whatever it is, you can bend this tube such that there is no direct flow between this pipe and this pipe. Both are different. You can operate manually, you can operate by solenoid, you can operate by air pressure or by fluid pressure. Here there is another one is given. See, here it is given, figure 2. Same thing, P to A and R to B. R means reservoir, same as tank T. Okay, P means pressure from pump. Pump, tank, A and B are valves. We will see more about this in videos.
In order to understand the
spool valves are found in almost every industry you can imagine, performing a wide range of tasks. As the energy source, there are several chambers drilled opening these ports, depending on the position of the spool. The spool can be moved
See,
in many different ways.
you can
Manually,
actuate with a
using
button, manual or lever. Okay, both are manual or solenoid.
or control system using a
Okay,
solenoid actuator.
now a simple valve is shown here.
Whatever the method chosen to control
Now
the
here this is
valve,
shown as
all that we are
pneumatic
doing
valve,
is
air
setting
pressure.
it
Assume
within the
that this is a fluid
system
pressure.
to move within the
You can see
housing.
when pressure is given,
And by doing
this
this, we
spool
are
will be
allowing
moving to this
or
side and
blocking the
cylinder will
path between the
go that
ports.
side. Okay, you can show here, see here
In
in
some
detail.
cases, there may be a solenoid at each cylinder is retraced
See,
because ports 2 and 3 are connected due to the spool
here it is
position.
air. Okay, this is air. Okay,
So
here
if your
nothing is
air
connected.
already within the system
Okay, you
will
can see
escape to the
when
atmosphere through
this
the
is moved.
exhaust port. Let's
Okay,
consider this the normal
see,
or rest
this is normal
position.
rest position.
Now
Means
imagine we operate the actuator.
at rest
We
without
will
any
see
actuation,
this
this will be
the
here.
position
So it will be
change
blocked. When you
position
operate, it will move to this side.
where it
Now gas will come
started.
here and it will move like this.
This is because the spool has moved position. Unblocking port 1 change position. The normal or rest position. Now imagine we operate the actuator. We would see the spool position change position and the cylinder extend. This is because the spool has moved position, unblocking port 1 and simultaneously blocking port 3, resulting in allowing airflow from port 1 to port 2 while blocking the exhaust. This is known as our working position. The cylinder will remain extended until the spool is moved.
This is exhaust post, exhaust port. Okay. Wait. Okay. You listen
Or
this.
by an internal spring return. The cylinder will remain extended until the spool is moved back to the normal position, either by way of another actuator at the opposite end of the valve or by an internal spring return.
Okay.
In our example, this type of valve and the cylinder
See red light
extend.
here.
This is because the spool has moved position, unblocking port
See
1
the red light here.
and
This means you are
simultaneously
actuating this
blocking
spool.
port 3,
So you are
resulting in allowing
pushing this towards
airflow from port 1 to
right
port
side. Now this has
2
operated.
while
Now
blocking the exhaust. This
pressure
is
will go
known as
to
our
left side
working
of the
position.
cylinder, that is
The
blank
cylinder
end,
will remain
which will push the
extended
cylinder to
until
right
the
side.
spool is moved back to the normal
When you switch off
position,
this, okay, it will
either
come
by
here.
way of
See
another
when the light
actuator at
moves,
the opposite end
lights
of the
you can see
valve,
here.
or by
When the
will
light is
remain
on,
extended
it will
until
move to
the
right side
spool is moved back to the
cylinder. When the
normal
light is
position,
off,
either by
this will
way of
come back,
another
return
actuator
because
at
of
the
this
opposite
spring.
end of the valve, or by an internal.
See here, when you are actuating, before actuation, this is at, see before actuation, this is in this position, rest position, means inlet is blocked. When you actuate, this will move to right side. You see. Now this is moving right side. See, moving right. When this moves right side, fluid will go like this, and cylinder will be pushed in this direction. It will remain in that situation, that state, till this is actuated. Once this becomes off, due to the spring action, this will return here. You can see here. Then this gas or fluid, whatever it is, it will return in this path like this. Now it is blocked because it is actuated. When this is actuated, this exhaust is blocked. You see, now this is opening. So this fluid or gas will come here and discharge either to the tank or atmosphere. Now this is off. So this is how a typical valve system works. Okay. Have another video which is not so easy to understand, is it? Nice one to move.
Circuit, you should know working principles of 5-port 4-way air-to-air valve. You can watch that video by clicking the link shown here, before proceeding with this video.
See here both a rotary valve and a sliding valve. Rotary spool valve and sliding spool valve both are shown here. Okay. So what happens here, how it goes, all these things are shown here. Okay. This operation is but this much is enough for you, I think. So you can see more videos here. See that this is the link. If you want, you can remember, type this and go to that particular channel.
valves. One of them is building a pneumatic reciprocating four-way rotary directional valve controls the pilot ports of 5-port, four-way air-to-air valve.
See here, instead of spring, okay, it is shown as double acting. This piston is getting supply from two sides also. So when you give pressure here, moving right side. When you give pressure here, moves left side. Here you can see now. See, this will open this, so like that. Okay, PARB. Okay, there are some errors in some figures also. You see, R means reservoir actually. This actually pump, mostly not tank. Anyhow, slight if there is error or some differences, don't bother. We are electrical students, so you just understand how it operates. In examination, you need not write each and every detail. You should know basic operations. For the whole hydraulic actuators itself, in our syllabus, it is given only 8 hours. Sorry, for a full actuator system, and for hydraulic actuators it is given only 1 hour. In 1 hour we study block diagram and the types of two types, single acting, double acting cylinder, hydraulic valves, etc, etc. So I don't think there is no need, I don't think there is need to study everything in detail. So understand basic operation. Okay, that is important, otherwise we will not enjoy the subject.